This video is for section 8.3. We just learned 4 ways to show that a quadrilateral is a parallelogram. So we're going to apply those 4 things to these shapes. Are these parallelograms? Yes or no? Why or why not? This first figure, I notice that all sides are congruent. We have a test for parallelograms that says if the opposite sides are congruent, then it's a parallelogram. So yes, it's a parallelogram because the opposite sides are congruent. Now, if we go back a couple sections, we talked about what you can call a parallelogram with 4 congruent sides. You can't always do this, but we know in this particular case that this is a rhombus. It's definitely a parallelogram where all of the sides are congruent. That's what a rhombus is. Number 2, is this a parallelogram? I'm looking at my opposite sides and they're not congruent. So I'm going to put no on this one. And that might not be the best answer. You really can't tell for sure that it's a parallelogram. That doesn't mean it's not going to be. You just can't prove that it is. The opposite sides aren't marked congruent. So that's just a congruent sign with a slash mark through it. Number 3, here's a 4-sided figure, and I notice that this diagonal is bisected because these pieces are the same length. Also, this diagonal gets bisected because those pieces are the same length. So this is a parallelogram. Okay, so yes, that's a parallelogram. The diagonals bisect each other. Number 5, we're going to skip to that one right now. In this shape, we have a pair of opposite sides congruent, and we have another pair of opposite sides that are parallel. This is not a parallelogram. Your opposite sides, one pair. So maybe I'll write that in there. One pair of opposite sides need to be parallel and congruent. Notice how we have opposite sides congruent and then the other opposite sides parallel. You need the same opposite sides to be parallel and congruent. And that's what happens over here in this one. We have top and bottom congruent, and then we have these alternate interior angles that are congruent too, which forces the lines to be parallel. If you guys remember back to that chapter, that was chapter 4. If you have congruent alternate interior angles, then that makes parallel lines. So we have a 4-sided figure where we have congruent sides and parallel sides. So yes, one pair of opposite sides are parallel and congruent. This slide is a nice review of all of the ways that we could figure out that something's a parallelogram. So we'll just quickly review that again. This shape is a parallelogram because the opposite sides are marked parallel. That's the definition. Theorem 8.7 says that this shape is a parallelogram because both pairs of opposite sides are congruent. Theorem 8.8 says one pair of opposite sides are congruent and parallel, and that can look a lot of different ways. Most of the time it just looks like this: congruent marks, parallel marks on the same opposite sides. Congruent marks, parallel marks on the same opposite sides. But sometimes you get these ones where you have your congruent marks on your opposite side, but there's no parallel marks. But if these consecutive interior angles are supplementary, then you know that these are parallel. Just like this one, which was what we just did on the last slide. Opposite sides are congruent, and these alternate interior angles are congruent. That makes parallel segments. Okay, and then your last one, the diagonals bisect each other. That makes a shape a parallelogram. Okay, so these shapes are parallelograms. This is the definition of parallelogram. This is that theorem that says opposite sides are congruent. This theorem says the diagonals bisect each other. This one says the opposite angles are congruent. And this one says one pair of opposite sides are both congruent and parallel.